Okay, successful project planning for mass timber projects. So I'm sure you know that I was involved as a senior project manager. I learned quite a bit about managing these projects and understanding what was more successful and what things we struggled with on Brock Commons, and have basically brought that information forward and started managing other projects and identifying those risks, the things that we struggled with. Okay. So just an overview, planning the site. We'll talk about how we assess the site, staging area, site deliveries, product constraints, specifically with CLT and envelope panels, preliminary project scheduling, integrated project delivery. I'm not sure how familiar you are with that. Here we use construction management terms of contracts for an integrated project delivery or design build version. Safe work plans. Plan your work, work your plan. This is a pretty straightforward, it seems, but not so much when we're trying to execute. And then water management. So trade input, planning the site, extremely important. Spend quite a bit of time with my site supers managing this, but understanding and fully integrating the review of the delivery needs throughout the entire project. It's fantastic if we're servicing an excavating contractor, but if we forget that at the end of the day, we're still going to be putting in final products into the building and the access points don't make sense, then this can be really difficult for the project overall. Here in Vancouver, we have to do strategic planning with the City of Vancouver in order to identify how our trucking routes are going to come into the city, because they have lots of infrastructure projects going on. So we now are constrained in at least 6 different communities where we have to communicate clearly what our project is going to look like throughout the entire time we're building and where trucking is going to be coming from. So we sit down with our superintendents and, more importantly, our trade superintendents, and we go through everybody's input from the form worker, the mechanical trades, the electrical trades, and identify how we're going to service the site. The size of crane is not necessarily determined by the largest item. It's interesting because the largest item often is our core boxes. Recently, we just determined there was a small but very heavy piece of mechanical equipment that determined our crane sizes. And it was just because we had spent time bringing in the trades at the very beginning and having the conversations that we actually picked that up and sized our crane accordingly. It wasn't a big deal. And then it allowed us to open up some constraints that we had put down on other items, and actually made our job site a little easier for us to manage. Ensure there's enough room for your water management and your staging areas. So one of our concerns is on our sites, we generally don't always understand how our laydowns are going to look like throughout the project. So we do multiple planning sessions. I'm going to get through this. So here is our first planning session. This is one of the first things that we do, is we look at what does our crane swing look like, what does our dewatering system look like, and where's our delivery area. What is the size of the trucking for the mass timber? It's generally the largest panels I'm bringing on site, and can I fit it in the space without affecting my neighbor's properties? Here we get pretty fussed about getting in front of other people's properties, and we can't rent the space in front of the other properties beside us. So this type of planning is extremely crucial. On the project, we initially thought we were going to put our dewatering system in here. We actually moved it into the back to get it out of our way, and found another way to run the water down alongside of this building and out. That frees up our entire space, so we can now have a full thoroughfare of our trucking coming in and out. We review all the weights and all the sizes of the trade equipment at the very beginning of the construction sequencing. So we bring in mechanical and electrical into the project very early, and we start talking about the size of their HVAC units, what kind of curbs are going to be needed. Is the whole unit coming as one piece, or is it going to be, can we split it and bring it in multiple pieces and maybe downsize the crane? Confirm how the building will be loaded for the entire duration. So one of the other concerns we've had, one of the things we learned on Brock Commons, was we couldn't put a hoist on the building because of the speed of the construction. By the time we would be at the top floor, the bottom floors needed to be loaded in. So we couldn't actually put a hoist on the building and be able to do everything we needed to do. The hoist wouldn't be able to do the service. So what we realized is we were going to have outriggers on that building just because of the speed. Since then, we've done other projects where we didn't skin the entire building, so that actually slowed some of it down. It's not ideal, but it was a budget constraint and one of the things we needed to think about. The other thing is, if you're going to use a hoist, you need to have space for it, and then you need to have access for it. And a hoist is no use for you if you're actually now in the space that you need to be in to be able to use. So these are all the types of constraints we're reviewing at the very beginning with the trades. It's really key, and we're finding it much more useful. It's just like all of the things that we've demanded of our design groups that we work with now, we're now demanding that of our trade groups. Our utilities, water management, and safety, this becomes a really big conversation. Again, the cities are starting to ask more of this from us, making sure that we're not doing anything to risk everyone. So we have to consider our timing for our hydro connections. Confirm is if we're here, if we don't pay it on time, we don't get hydro until between 12 to 24 weeks after we've paid. So that could literally blow out your entire timing for your building and turnover. Confirm the remaining connections existing plan. For here, we need to make sure that we do all of the survey, and then the city comes back and actually confirms it. It used to be that we could actually get that information from the city, but because I've had multiple contractors doing work over the years, this isn't efficient and often is incorrect information. And then again, we talk about these environmental takes of what size are they going to be for the duration of the project, because at the very beginning, we'll have larger tanks, and eventually we'll go down to a smaller tank system, and where can we tuck that away? And ensuring we have a convenient location for the temp hydro for the entire duration of the construction. We certainly don't want it in any way, shape, or form in the way of the panels moving over top or around that unit. Then the site safety plan. The site plan needs to include all the emergency information. This is extremely important because this is our communication tool that we're sending out to the trades, even in the form of contract. It's also posted on all our safety boards, but it's an actual live document that's constantly being moved around between ourselves and our trades. We're finding that more effective than just posting it on a safety board, because we find a limited amount of people read it, even though they're obligated to do it. Then the staging area. So this is interesting. One of our projects currently is sitting right here. So it looks like we would have access by a number of different locations to get here. It turns out that's not the case. All of this area is actually fenced off. Google lies. And so all of this area is actually fenced off, and this isn't actually how it looks. And what we found now is that the panels we want to bring in for this particular project, we had anticipated would come in here, but they can't make this corner. This is a very, very busy street. And now how do you get these panels in here? And there's another very busy street on the other side, and turning these large trucks around. So this is what this type of things that we're required to think about. By reducing our panel sizes by about 4 feet, we actually can make the corner by driving up onto the city sidewalk and coming in. So the constraint of the panel is unfortunate. We would have preferred to go as large as absolutely possible. Trucking makes it nearly impossible for us to work. We can't actually encroach in this property, and to make this turn, we can't get in here unless we're under 50 feet. And so our 53-foot panels no longer work. Then we have to talk to the city about doing road closures. We're going to be backing, or we'll be taking our truck in, and we're going to be backing into the ramp. And this is going to be temporarily closed for a duration of time. So those are things you need to think about. The cost of that gets very expensive. It depends on the city we're in, but this can be very, very expensive. So this was all adding to our costs of CLT when we're doing our cost analysis. Is this cheaper or more expensive to use CLT? Should we be doing concrete? Should we be doing stick frame? What are we looking at? Even after all these constraints that these panels were putting, or this trucking was putting on our panels, CLT was still the least expensive and definitely the fastest product for this particular project. And then we consider the full access route to site and how we would get there, and if we have any staging areas to put our material. What else? Just a quick check, make sure I haven't forgotten anything. Okay. Next one, optimization of the pre-manufactured product. So this is a bit of I touched on this a little bit before, the project constraints. So this is a really cool picture of the panels we were using for envelope from Brock Commons. Some of these panel sizes, though, on this other project I'm working on simply wouldn't work. We can't fit this panel onto a truck. So this is just talking about that pre-manufacturing, those actual size constraints. We always, again, the other item would be that we always try to optimize our panel sizes, because obviously we have a size of a crane, and if we can use the larger the size of the panel, the faster the installation goes. We also consider how many times we pick from the crane. So we generally can do 36 picks in a day. And if we can manage to do our entire floor plate and our walls, because we're using CLT walls and some columns, if we can get that all in one day, that's a 1-day cycle. And then we do our envelope panels in 2 days, that's now a 3-day cycle. So, you know, every day that we're doing picks, multiple picks, it can actually delay the project by multiple days. So the original constraint on our project, some of our panels were going to be too short. They were going to be very small panels. Due to the seismic constraint, and we had to figure out a way around that, how we could still meet the seismic constraints but actually have much larger picks. And we managed to figure that out after probably 6 or 7 meetings with several people in a room, including all of the installers. Figured out how to make optimize those panels into the largest possible, reduce our picks down to 35 picks in the 1 day, and that means we can still work a normal day and complete a floor plate. So construction timelines. Full construction timelines. When we build a schedule for the budgeting and the pre-construction, we do a full construction timeline. So we don't even, normally what we were saying is we kind of bulk items. These are generalizations. We actually go through the details and try to actually support and figure out what is the real time. We'll phone up trades and talk to them and give them an idea of what we're up to and have them give us some real input so we can develop a real timeline. It's a little trickier because concrete, everybody has a good feel for, and they have a good idea of how much time it takes to do a floor. They understand all the reshoring, which I think is some kind of, we call it some kind of a post thing. But basically we come back and how long that takes. So from that, we actually go now to the trades and we have a discussion about how much time does all of this take from your perspective in real time. If you had everything exactly the way it needed to be, what does that look like? And then we start building a real schedule around that isn't held by concrete timelines, because concrete tends to be quite a bit slower for us. Okay. Then the procurement times, which almost 100% of the time this is missed on the general schedule. A full understanding of it. There's generally procurement times as it is addressed by shop drawing schedule, but it very rarely reflects the actual timing of everything. So shop drawings, how much time does it actually take to approve a shop drawing? And it's not 3 weeks, like as it would suggest in a contract. On average, approval of a shop drawing is 2.5 months, to be realistic, and that should be identified in a schedule, so it's not a joke schedule. Then the other part of that is the product. To produce the product, how long are we talking? A lot of trades will give us exorbitant numbers and say it's going to take us 6 to 9 months, when in fact it isn't, it's 3 months, but they're worried about the timeline for the shop drawing schedule, so they're giving us blown out numbers. So getting a really good handle on that. And then the timeline and payment requirements, like what kind of deposits are we looking at? How do I secure the cost for this project? So here we're experiencing huge price influxes for our wood, for our mass timber projects. Almost 20% increases over the last year. They're starting to come back down now, but as late as the end of September, they were almost 20% higher than we originally budgeted. So we locked in our pricing in April, and that kept us at a much lower price, but other projects weren't so lucky, and they're definitely seeing now they have to make the decision, does CLT still make sense for them? Excuse me. Next one. Then the adjustments to site to receive the product. So now you have to really, you went and put a site plan together, you have your theory, now you've communicated that to the estimating team. Now we're getting further into the project. Now we're starting to talk about procurement of the products, what the product actually looks like. Now we're confirming our equipment. What does need to be installed on site, and when does it need to be there, and does it have a long lead? Do we need to leave those openings in the slabs for some of our equipment deliveries, and what does that look like? Because with mass timber, it's a little more tricky sometimes if we're leaving openings inside of slabs so that we can drop in a large piece of equipment and not slow down the site, then to come back in later and put that panel back in, not necessarily the easiest thing you could possibly do. So you really need to think about, does that make sense? Maybe it's better to delay the timing of the project, maybe modify how that infill is going to be done, and does it require specific equipment, and what are the costs of that? So for us to come back and put a generator in a slab that was forgotten by the team was basically, we had to get rid of the CLT in that location and put in a formwork slab, because it's just impossible to be able to get a crane in there inside and deliver the CLT on that particular level. It's just things you need to consider. The mistakes that we made, you shouldn't get to make. I should be able to give you that information. And then when you're enclosing, obviously enclosing the slab, what does that material look like, and how would you receive it? And now I've got trucks, not just mass timber, but I've got concrete trucks on the side at the same time. And so that planning, all your best laid plans need to be considered. You have to consider all of this timing. Long lead items. This one's the most interesting. I don't think I've been able to convince anybody that the long lead items aren't always normally apparent unless you do the first two exercises. So from the procurement timeline, it'll become apparent was actually the long lead items on the projects, but the speed of the manufacturing and no requirement for reshoring is a big issue, because if you're only used to doing concrete buildings and you're accepting that you're going to have 5 to 8 weeks of extra time on the project, in fact you don't have that, now things start having to come along a lot faster. One of the largest mistakes we made in Brock Commons is we truly didn't understand how fast we were going to build, and it was pretty amazing to see the superstructure and the envelope panels go up within 3 days in a 3-day cycle. However, our interior finishes were nowhere near that timeline because we simply didn't understand at the time how fast the building would go. We had tried to bumble along and do some pre-manufacturing, do some mechanical pre-manufacturing and pre-purchasing and having that install. But in fact, when we got down to it, there was at least 5 to 6 floors empty at any given time on that building because we simply hadn't set up the rest of our trades for that level of intensity and set them up for that level of success. So a lot of attention needs to be then paid to how do you get the finishing work up to speed, and how do you get that to, you're not going to pace it at the exact same pace unless you can pre-manufacture the entire building, which isn't impossible, but it's about availability and who can actually produce that. So things not necessarily apparent was the millwork actually needs to be quite a lot earlier. You need to consider other things in your envelope panels and how that's going to come together and how that's going to affect the rest of your space and all of that timing. You'll understand as you go through your detailing. As you figure out your details, you'll start to understand, oh, these things are actually going to happen a lot faster, or this is going to be a problem because it's going to take so much more time and it's going to slow down all the other finishing trades. So those types of conversations really need to be had in long lead item conversations. And that's the benefit of the integrated project delivery. If we have enough people in the room with a lot of different levels of expertise, then we can have the conversations about what actually happens on site. Pricing options. So this is one of the biggest benefits of an integrated project delivery. Pricing is done throughout the project delivery. So we start with a class D, we work our way through a class C, and we just keep going. And as we develop drawings, we continue to bring this budget into play. And then the other item that we do is we have meetings with our estimator involved, and we have like real-time reviews of product so that they're involved in the products as well. And they decide what makes the most sense. This is definitely providing better informed decision making, and it's allowing everybody to decide, oh, that product is very expensive and probably not a good fit for this project. Then we do cost comparisons between steel, our concrete building, a stick frame building, and we decide early on, very early on, what budget works. So one of the examples here is a budget that we've been carrying through, and does it make sense, and what's happening to the budget, and the different things that we've been doing to it. So this is like the level of conversation that we're having regularly with clients. At least once a month, we're having a monthly updated review in an integrated project delivery about what the cost is. So everybody's making informed decisions. And then we also have the key trades involved. So for us, our key trades are our CLT supplier, mechanical, electrical, our concrete formwork, and our, we have an issue with our soil conditions, so we have an excavation contractor early. And then that leads into maintenance considerations. So depending on what's being considered for the project, so is it going to be a predetermined sale? If it's going to be a sale, then we might consider products differently. We might go for more expensive, but flashier, but something that may need to be replaced in the future, but it'll sell better. If it's going to be owned by the client long-term, I have several of these projects now that the clients maintain them as rentals. Then we process the decision-making differently. Where do you want to have long-term materials, and where do you need to do replacement maintenance? And that's going to drive your costs in different directions. So long-term, more durable projects tend to be more expensive. We revisit them up to, we look at it from like a 10, 20, 50 year cycling. So do we want is this something that's going to need to be replaced regardless in 10 years because it needs to be updated? Or is it something that we really would like it to be 50 years before we do an update? So we start making those considerations, like lighting. We tend to believe that lighting is going to be changed within 5 to 10 years. And our wall panels are we want our wall panels to last 50 years plus. So those types of considerations need to be made ahead of time. And then, is there a history of maintenance issues within other projects that you're aware of? And if we're selecting those products, you know, it's our job as an integrated project delivery to advise on that. So the client isn't just left with, we know things, but we're really not sharing. This is fully, everything is on the table. We share everything we know. We give our full experience and knowledge to the entire group. And then one of the nearest and dearest to my heart is ensuring that maintenance is easily accessible. So one of our biggest problems we've had in the past is that equipment is not accessible after it's built into place. An interesting unit, a Zender. I don't know if you're familiar with the Passive House Zender unit, but the filters are in an interesting location, and to access them, you actually need a lot of space because they come out on 45-degree angles. And they don't fit into a closet very easily, and that needs to be considered. And if you're doing that and you have to now open up a wall every time you need to change a filter, it doesn't become a very useful way of building. So those types of considerations need to be made. Maybe that's not the best product, or maybe it is the product that needs to be there because it's the only one that really works, but maybe we need to make a better consideration for the space. So we just go through, and we literally go through every single item, and we consider, does this product make sense for the project? Is this the best option? And what does that mean for the project in terms of sizing, spacing, and considerations? Schedule. We compare products. Again, we talked about this, or I talked about it earlier, CLT versus concrete versus stick, but we compare this. This actually helps inform our budgets and determine which direction you're going to go. We do find our CLT numbers are coming in lower than our concrete. On average, it's between 3 and 5% lower in CLT versus concrete. Stick frame, it's still cheaper, but we don't like the overall product for durability long term, and it has a huge insurance risk on stick framing. So, and then the steel here really hasn't taken off in the Vancouver market, so it's not usually something that's considered only as a hybrid portion of the CLT. The other thing we talk about when we're considering as our hybrid options between CLT, concrete, and stick framing, every one of those can have variations of hybrid options. Specifically the CLT ones, we usually marry up our CLT panels to concrete or to steel columns. And then we're talking now about panelized concrete cores, because we were just running into having huge thickness issues to make a CLT core. And we need to marry that up with steel in the event that we wanted to go higher than 10 stories. After all the work on it, we realized it wasn't impossible to do a concrete panelized version, and it really works very well with the CLT. The timing works well. You can do a floor by floor, and it gives you a nice momentum on the project. So again, all those things were happening, all the pricing is happening. We're constantly making considerations. What does that look like? What does that look like? And how does that timing work? Does that make sense? Time is money, right? For us, it's between $250,000 and $280,000 a month with a crane on site. And we want to consider that price tag. Having that is very expensive. And if we can reduce that time, that alone is a large chunk of money. Then on top of that, you have carrying costs for financing. CLT and envelope panels on a multi-story building can reduce the superstructure and envelope installation by half or more compared to concrete. That definitely, we're proving that one out regularly now. A little bit of planning, but you really do need to marry the CLT up with an envelope panel that is completely skinned, and you have your air tightness within that envelope panel system. That's how we're making the time up. If we go and put up an envelope panel that doesn't have the skins on it, and we have to come back later and get our air barrier and then put on our insulation and our skins, then we're finding that we're not gaining as much time. So we're not really not winning when we don't marry an envelope panel to a CLT panel. More time spent on drawings and design in the front end means less RFIs and change orders in the field. That we proved out in spades on Brock Commons, and I see it regularly now. We spend most of our time for the first 6 months before we even break shovel in the ground on RFIs and change orders, and we do all of that in anticipation of producing a perfectly good set of CLT panels with the intention to have no extra site cuts. That is a successful project if we can pull that off. And so far, we're doing really well with that. It takes a lot of time and effort from the entire team up front, and we're talking hours and hours and hours of time. However, what we're finding is we don't have the time during the site, that we're not dealing with RFIs and change orders and site instructions on site, because it's actually being built on spec when you do the effort up front like this. And then the attention to timelines to ensure the project is designed to complete IFC documents ready for manufacturing. So when setting out an integrated project delivery, and when I'm brought in, I identify the timelines and what that looks like with your shop drawings, so that your IFCs are coming in at the right time to support getting shop drawings. And so we get to about an 80%, not quite IFC, but an 80% drawing. We start informing it with shop drawings at an earlier level. And then by the time we're through the shop drawing review and we've identified all the penetrations through the CLT, and that shop drawing is nearly complete, then we're hitting an IFC level drawing. And that's the drawing we're going to build off of. And that's the one that's been extremely coordinated with all the RFIs and all the change orders and all the different options. That's all been considered, and that's what's being used. Then we go into the additional pre-manufacturing and our envelope panels. So our envelope panels, this is key for us for maintaining our CLT installation. We get a lot of rain in Vancouver. There's very few weeks that go by that we don't get rain, so the benefit of having an envelope panel in place quickly is pretty important in order to keep the building dry and be able to continue work from inside. This is also talking about all that timing, getting all those trades moving on the inside of the building faster. There's no requirement for safety rails while the envelope is being installed, and that was key. So as you see in the photo here, the guy is installing, he's harnessed and he's installing the envelope panels, and after those go in, they're locked into the building. That's a final destination for them. We no longer require harnesses. So we actually cut out the need for safety rails by doing it this way. And that's a huge time advantage for us. The next one is that we require no scaffold. By having no scaffold, and because the cladding is part of the building on installation, this is really important. In the future, so in Brock Commons, we didn't have balconies. We have balconies on our other projects, and we do those as a clip-on to the building. So we found different clipping solutions where we can clip them into the building using the crane, and then that becomes a safe, basically a safe zone, and the railings are all integrated as part of that, so it just basically locks on and they keep going. It is a tricky detail. I can't say that it didn't take us a long time to solve it. It took us months to figure it out with lots of very creative people, but it isn't impossible to do it. Then the next thing, air barrier requirements. Well, they're easier, we find, with the envelope panel solution, because it's actually, we predetermine that ahead of time. It's the quality control in the plant helps ensure that those panels that are coming to site already meet the air barrier requirements. And then when we seal them the rest of the way on site, we're definitely finding we're meeting our goals and achieving them much, much easier. We're getting to passive house standards now without a ton of effort on the air barrier. When I try to do this in situ on site, it's nearly impossible. Reduction of materials to site. This one is mind-boggling. Between the CLT panels and the envelope panels, having those two items not trucked in to build in place on site, and then all that garbage trucked off site, we're talking about hundreds of thousands of dollars of savings in bins and trucking. And that's huge, because a lot of these sites that we work on now are much smaller, much more condensed areas. Panelizing the envelope immediately seals in the site, protects your mass timber, and this was one of the comments earlier, it helps you manage the finishes below. Additional pre-manufacturing, things that we learned. So once a decision is made to use mass timber, we consider all the other types of manufacturing that needs to be made. So then we talk about the millwork, the plumbing, rough-ins that need to be pre-cut. The mechanical room is pre-manufactured. All our interior, on a couple of our projects, we're now doing interior walls. It's not the easiest thing because it's new, and we're trying to develop a theory on how to do it easier. But we're trying, because we believe that if we can get our interior walls pre-manufactured, it's going to save us even more time. We do all our staircases pre-manufactured, and then of course the envelope panels, which is a really big time savers. And we talk about safe work. So once we've got all that planning going and we're into everybody getting ready for the pre-manufacture, the site team goes back to the safe work plan. So then we work out a full safe work plan. Not all companies do this here. I'm a really stickler for this. This is important to us. So you quickly identify all the steps that are not always obvious to complete. And then we typically, a site safety or safe work plan identifies the sequencing of the installation on a plan or a drawing. So I like the plan view drawing, and then we identify what's going to go first, what's going to go second. This also helps lead into 2-week and 3-week look aheads for the foreman for the site. We identify all the pieces of the installation, what needs to be done with it. So it is a metal torque wrench that I need to have on site to torque the bolts for steel connections. If that's required, we need to know that. We talk about all the rigging, and if there's engineered rigging that's required, we make sure that all the certifications have been provided in the safe work plan so that we know what we're looking for when the things get to site. We talk about all of the certifications of all the manpower. We talk about all the rigging in that safe work plan and what's required and what we're looking for. So basically we figured that whole plan out. We also do, in the planning, we talk about safe work zones and any kind of like no crossing zones. What are the slings looking like? What are the taglines look like? How many radios are required to actually perform this installation? And then also would highlight any major lifts for us that would have to be specifically engineered by a local company here. So, you know, sometimes our generator is a little iffy, and we like to just go the extra mile and make sure that we have that as an engineered lift, just so everybody feels comfortable. When we are on projects, when there's a new team in construction that to CLT, we tend to really recommend to do this so that everybody has a good handle on where they need to be, where they shouldn't be. And this creates a really nice way of discussing, like, the CLT panels are going to go in really fast, and there's places you just don't want to be when that's happening, and you don't need to be when that's happening. So, you know, those types of discussions, this really helps. This also helps it by supporting it to the rest of the trades. And this here highlights, this is one of the things we did at Brock Commons. We actually highlighted the entire sequencing, and then we were able to produce it exactly the way we said we were. I'm just going to show you a little video. So the importance of the video, it's really sped up, but there's like this, there's a safety box in there that's considered, so the size of these were actually made so that the safety box could fit in at any given time. Originally they were going to be narrower. Even these like planks on the sides here, that was considered at the very beginning. They weren't considered. They looked at their entire situation very differently, and when we put it all together, we realized, oh well, we're going to need access around it, we're going to need access through it, and so all those types of conversations started to pan out. I don't necessarily always do this type of level of safe work plan, but what I'm finding is with specific trades that are difficult to manage safely, they're newer. We've picked them because they're cheaper and not because they're better, but we've been driven by a client to do it. This is where they spend their money, to make sure that nobody gets hurt. And we really do try to simplify this plan. Like, we worked through that to make it as simple as possible so everybody knew what they were supposed to do. Next one, water management, my favorite. Teamwork. It's not just about the GC managing the water on the site. He's not going to see everything. He's one guy running around a job site. It's just crazy to think that one person's going to know everything. I'd like to be that person, but it's just not possible. So just as it's everyone's responsibility to be safe, it's everybody's responsibility to manage the water. So we try early on, like day one, we establish a culture on the site to make sure that everybody's working towards the same goal. So if there's a flood, we all stop work and we save the flood. And by doing that, everybody doesn't want to save, like the water is flowing. Not everybody wants to run and deal with water, but I found that by making everybody accountable to it, then all of a sudden, everybody that walks by it and realizes, hey, this little kiddie pool is absolutely full and obviously it needs to get pumped out, there's a conversation and it's relayed really quickly, instead of, I've got water now on the lower floor that I didn't expect to find. We also found, and as you can see here, this actually is quite common in our mass timber builds. It's a very, very clean site. So it is easier to manage the water and as long as we're maintaining a clean site, we were finding that it was much easier to manage water. Clear communication in trade meetings, what's expected, what are they expected to observe, what are they expected to come tell us. Just keep an eye on the time. Specialty coatings for mass timber, some of the discoveries out of Brock and other projects we're on. So we always wax our ends to help with the moisture that's going to travel into the edge grain, into the CLT. Before I get everything covered, I want to make sure those edge grains they've been waxed, and I don't want to see a ton of moisture coming up those edges. The other consideration we do, especially if we're getting into like shoulder seasons where we know we're going to get a lot more water, we consider to coat a spray applied water repellent product. There's a couple of companies out here that do them, and most of the manufacturing facilities can easily do this, although they don't like doing it, but they can easily do it. And this just basically makes it easier for us to just squeegee the water off the panels. Now the stuff on here is very shiny. We wouldn't recommend that. It won't bond to concrete, but the other stuff we're working on does. It works a lot nicer and it bonds nicely. Then we also look at a fire-rated spray applied coating, and this was for the verticals we've been working on, and we've traded that out for drywall or fire-rated plywood in some of our staircases. It's just another solution. There are multiple solutions out there that are available to you. Concrete topping. We still are firmly believing in the concrete topping to help us the most because of the amount of water we get on our job sites. So we use a concrete topping that basically helps us tank. We've changed how we do our connection detail with our envelope panels so that we now actually have a flashing detail that comes up in here. We no longer need to have a little curb detail on it. So basically we tank right out to the envelope panels and we end up with a really nice surface area to cover. We use a chamfer strip, so if you're not familiar with it, it's a little triangle that we run between the columns that basically just sits just underneath the top of the concrete, and it forces the cracking of the concrete into those locations, and then we tape that off on the floors that we want to tank out and make sure we have no water moving down into the lower levels. The other thing that we have done on our balconies and some of our rooftops, because we haven't had a chance to get the roofing in fast enough because we have a bunch of other sequencing of elements that have to come in, we've been using an alternative. It's a breathable waterproof membrane, Proclima, and there's a few companies out there now that offer these options, and it really does help manage controlling that water. Fans and dehumidifiers, I found during construction in the warm months, no problem. Fans, great. Squeegees, it's great. In the wintertime, we were really relying on our dehumidifiers. Once we get the drywall in, it gets really hard to control the humidity in the space. That's not unbeknownst to anyone, but we were using electric heat a lot more here. It was a little easier for us to manage. And then the benefits of mass timber, pre-planning. It's awesome. If you spend the time and the effort and the energy in the pre-planning, it is an amazing product come the time that you start doing that installation. It builds like a spec. It builds like you're putting together a model car, and all the pieces are there and you just put them all together. You get a real completed, coordinated set of drawings. We insist on Revit modeling between all of the consultants, and we're really finding this super helpful moving forward. And we rely less and less on companies like CAD makers to do all of our clash detections now that all of our consultants are doing proper Revit models. But we still do a back check with an independent company like a CAD makers. There's a couple of other companies now that do them, and check and make sure that there's no major clashes. There's little to no construction errors on site simply because we actually have something to build from that nobody has to interpret. There's no interpretation. It is what it is. The document tells you what you're building. And you have a complete and properly coordinated installation schedule. So that's also following back to that safe work planning, making sure you plan all of that work, make sure you have the timing right. And then nearly no changes on site. I've mentioned it a few times. It's a really big deal because time made or spent making changes is actually time spent away from producing an overall good quality project. The higher we get a much higher level quality control during the construction when we do these types of projects. Mass timber has been my most successful high quality projects. And that's the end of that. So I will stop sharing and I'll turn it over to you.
So we do have some questions here, Karla, that have come through as we've been going. So Jeff has asked, are you using a true integrated project delivery where the consultants are team contracting partners?
So I have 0 clients that are interested in that. I would really like to do it, but most of my clients are terrified of the idea that they would share a profit. So the way we've approached it is in a true construction management agreement. So we have what we call 5A and 5B CCDCs. Basically, we set out a higher level of fee at the very beginning because there's no change orders for us. There's so little change orders, there's no benefit to it. So we have a much higher level of fee than we would normally have gone after. And we do have a proper contingency that is viewed by all, but we don't win it back if we're successful at not using it. The client takes that. It is what it is.
There was a question also that was just jumped around here, just on the planning software you use, which looks amazing for that safety work plan you did. So what type of planning software do you use on the projects?
So that was with CAD makers. That was a CATIA program with CAD makers. And they actually use another one, and I cannot remember the name of it. I can't remember the name of that other product. But anyways, they actually work with me on that. I come up with the sequencing and the details of how I want it broken down. I want to see this, then I want to see this, then I want to see this, and I want to see this, so that we're communicating clearly with the trade of what was expected of the site. But I personally don't do the software. I am a software challenge. I can actually screw up a phone. It's really easy.
We've got a question here, which is a topic running out here in Australia at the moment. Is obtaining builder's risk insurance a cost issue on any of your projects?
Well, it was, interestingly enough, about a year ago it was, but I've managed to find a couple of companies now that have become competitive, and I pitched them against each other. So now I'm getting better numbers. It's the trick is to find two companies that are willing to stick their neck out to do it, and then you pitch them against each other to give you better pricing.
Yep, and that would certainly be our advice out here as well. There's companies that will do it.
And,
Companies.
well, and the other thing is, if you can prove you're a proven builder and you've done it a couple of times and they feel more confident with you, then it gets even easier to pitch that. I want a better price.
And a question here, do you have any projects using CLT exterior walls?
I do. I have several. I have a load-bearing exterior wall on one project, which is really cool. And I also have another one that's just, it's load-bearing, but it's not a requirement of the project to be load-bearing, I guess. But the one is an absolutely integral part of my seismic solution for the build. We went through mega hours to figure out how to make that project work and to reduce our fiber content.
Okay, that actually leads on to a question here from, you mentioned earlier on, someone asked how the seismic conditions do affect panel size.
So seismic likes to have my panels chopped into little pieces. It's like, it breaks my heart every time because we don't want to do 1,000 picks for basically a 40-foot panel that we could pick with the crane. They would like to see that in 4-foot panel widths, and it's not possible for us. But what we've done is we've figured out we can do a 40-foot panel, and we do a relief in the panels, and then we come back and we cut them on site and reduce it by that. That allows us enough movement during a seismic event so that the whole thing can then move and shake together. Very, very creative timing solution, but that's getting a lot of people in a room and having like major sessions of, I refuse to lift more than 2 panels, and the other guy going, no, this has to be 18 panels. Yeah, and it's a good thing we're on Zoom. I'm glad we weren't in a meeting room that day.
A question here just about sort of fitting up with other structural components. Are there any fit up or other structural constructability issues, either CLT to CLT or CLT to other materials like the concrete core?
I don't have major issues with that because that's all that pre-planning, and we literally make all the considerations on like, what does this connection detail look like? I'm on iteration 6 on one project for the detail connection because the first one was really rough, wasn't going to really work. The second one would mean we'd have to actually stop a truck and drill in a bunch of screws. That wasn't going to work. So we've literally, like, we'll go through those iterations until we find something that suits the site.
This was an interesting question here. I sort of had the same thought when you mentioned about those spray applied fire rated products. Are they code approved in Canada or just BC?
Yes, they
Maybe
are.
talk a little bit more about those. I don't think we have them out here.
Yeah, so that's Sanson. I'm using Sanson, and fantastic group. They're really creative, and you can work with them quite easily and get better at, like, they'll work with you. They want to be the #1 distributor. So I have no problem working with people that are willing to go the extra mile, and we can figure out really cool ways to use our products. But it's fun to watch them do the fire rating test on that product.
Question here from Andre. Do you have a distinct fire safety plan for the duration of the build, or is this incorporated into the overall site safety plan?
We had multiples during the duration of the building. So we have the first one, which is for the city, and so that they know what's expected. We also have one with the fire chief for the local jurisdiction. And then we also do multiple fire safety plans throughout the time we're building, because it's different when we're building the CLT and we have exposed mass timber, than when we're actually fully encapsulated and the site may not be easily accessible. So we do that discussion. Here we're required to have our standpipes up early, and I kind of jinxed myself with Brock Commons by putting them up early and having them ready to run, because now everybody wants that, and that's not always the easiest way to do things. But yeah, we definitely work through that with the fire department too.
You mentioned about waxing the ends of the CLT. That's an interesting one. Does that actually happen on site by the builder, or does
no? That happens in the factory, and I'm adamant about it. And I get lots of complaints about it, but I have really found that super helps us on site manage moisture inside the panels.
Okay. Is there a specific type of product you use there, or is it just a sort of
It's just a wax. There's a bunch of different wax products available. Some of them come out of the States, some of them come out of Europe. But if you look it up, CLT wax, well, I know because of the stuff I search on Google, they know what to look for. But if you're looking up that kind of stuff, it's quite easy to find usually.
I was also interested in your comment before about how you need to understand and appreciate how fast the buildings go up. You know, that intensity and speed on the other trades. So like, which of the trades in particular have you found that have caused you a problem that we should be aware of to?
Oh man, I have a list. My elevator contractor, this is the one big one that people miss on those so when that was that description of pre-planning and understanding, one of the things that always seems to fall out is that my elevators need to be ordered before almost a month and a half to 2 months before I break ground. I ordered my elevators almost 4 weeks ago, and we haven't even done the demo on the building. But they will barely make it on time. So that's one of the big ones. And then on site, my most painful trade is my drywaller. It's almost impossible for them to keep up. So that's why we've been looking at pre-manufacturing interior walls. Not the easiest solution, but maybe in another year we'll have come up with a really fail-safe solution that works.
That would have been a big one for Brock Commons, wouldn't it? Because after that beautiful timber building with all the plates and columns, it all got full of drywall little apartments.
Yeah. Well, I mean, there is a reason to do that too. So on our like low income housing ones, we actually cover them all up on purpose. There's no benefit to leaving anything exposed because it'll just become damaged. So we literally on purpose enclose that.
It was interesting, early on in your presentation, you spoke about the shop drawings and production timelines, how they get blown out in terms of the assumptions. Yeah, I was surprised with the shop drawing one in particular, how long that took for sign off.
Yeah, well, that's the thing. So because we have so many iterations, because it's integrated project delivery, we may have another iteration because the client, this is the time where you can make changes. And we go through the shop drawing process and we look at it and go, oh, this is not exactly what we were looking for. And now let's start the process again. So you need to allocate enough time for that process. Hugely beneficial though, because then you end up with exactly what you planned on putting in.
And the production timeline was interesting. How many suppliers of CLT now have you got in Canada? How's that taken off over the last few years?
I've got 3 on the West Coast and 3 on the East Coast. I have 4 actually technically on the West Coast, but I tend to use 3 regularly. And they're very competitive amongst themselves, so it's quite useful.
And what great projects have you got coming up? What would you like to see in terms of where mass timber's going with all your experience?
Well, I tend to stick to the, I'm between 6 and 12 stories. Those are the buildings that I'm like near and dear. They're really nice builds. We don't get into crazy seismic situations, and they're easily reproduced. We can do, and we can become really creative with them. One of them has a really unique floor plate, something that concrete could never have pulled off, simply because our floor plate is constantly moving, and the time frame and the amount of form work that I would need to do that would have like been 5 times the amount of time for a concrete build is like nothing for a CLT building. So that's the uniqueness of working on projects like this, where you get to be more creative. Yeah, that's the types I'm sticking into. And then the other thing that I'm spending a lot of time trying to work on developing is balconies, working with different groups on balconies and trying to figure out what makes the most sense for balconies. We don't want to build square buildings. We want to build buildings that are interesting, and everybody wants balconies. So how do we do that? And so far we've come up with some solutions, and some the engineering has been pretty incredible, and we've come up with some pretty really creative builds, but they're very expensive. The trick has been to come up with really creative builds that are very inexpensive and very manageable.
Well, we'd love to know a bit more about the balconies when you start to get that under control, because balconies definitely are a worry durability wise. So it's a really important part of the projects. Look, we're just about on time. I'd have to thank you once again. It's been an absolutely amazing presentation. We're so fortunate to have someone with so much knowledge on these topics. So I'm sure everyone online's taken away some great knowledge from today. So thank you once again for doing it live. Worked perfectly. Congratulations.
Excellent. Thanks, guys.